going to start off our study today by just thinking a little bit about what it means to have a solution to an equation like y equals 2x minus 5, and exactly how does that tie in to a graph of y equals 2x minus 5. We graph those last unit, so we know what the graph looks like, but what is a solution, and how many are there? Well, we can come up with solutions all day long. For example, if we let x be equal to 0, then y is going to be equal to 2 times 0 minus 5. So y is going to be equal to negative 5. So we have the point 0, negative 5. If x were equal to 1, we could come up with that y was equal to 2 times 1 minus 5. 2 minus 5, so y is equal to negative 3. So we have the point 0, or the ordered pair, 0, negative 3. If x were equal to, let's just make it, say, a 4. If x were equal to 4, y is going to be equal to 2 times 4 minus 5. So that's 8 minus 5, and that's 3. So we have the ordered pair, 4, x is 4, and y is 3. We can plot those points. So we have 0, negative 5 right here. We have, oops, this wasn't a 0. Sorry. That's a 1, isn't it? So it's going to be 1, negative 3 right here. And then we have 4, positive 1, 2, 3 right there. So we can plot points, and we could plot points all day long by putting them in and filling them in. And as we fill them in, we find out that they were all points along this line that had a slope of had a y-intercept of negative 5 and a slope of up 2 over 1. But it looks like that, and we generally will draw that with a solid line because that means that every single point, fractions, decimals, the whole works, are solutions on there. So this would say that at the point 3, I'll leave that color, over 3 up 0, so the point 3, 0 is going to be a solution for y equals 2x minus 5. So if I put the point 3, 1, so x is 3, so 2 times 3 minus 5 gives us that y is equal to 1. Every point on that line is going to be a solution to the equation. So each solution is represented by a point on the graph. So today, we're going to be talking about systems of equations. So we're talking about a system of equations. And a system of equations are 2 or more equations that we're considering at the same time. And a solution to a system of 2 equations is an ordered pair, x and y, that satisfies both of the equations. Some examples of possibilities, if we were to graph them, we could come up with 2 lines. There's my first set of ordered pairs. There's my first line. Here's the second line. They're going to intersect. So the first line, every point on that line is a solution to the equation. For the second line, every point on that line is a solution to the second equation. So what we're going to be searching for is the solution to both of the systems, both of the equations. And that point would be this one where they cross. It's on the set of ordered pairs for the first one and for the second one as well. So this one has one solution. One solution right there in the middle. Another situation that could come up, we could have 2 lines that were parallel. So how many solutions does it have? So if we're asking that question, we're asking where do the 2 lines intersect each other? And they don't. So this one has no solution to it. We can tell by looking quickly. And this last one, the last situation that can happen is that we can have a line and then another line that actually kind of lays on top of it right there. So they're actually the same line. So this one has multiple ordered pairs that will make both of them true right there. So multiple. So there are an infinite number of solutions. So every point on those lines are solutions to the system. So because we can look at a graph and see exactly where the intersection is, well, not exactly, it's going to be an approximate guess if it's going to be right or not. We could solve a system graphically. So that's our first method, graphically. So to solve it graphically, we might want to take each one of these and solve them for y. So I've got y is equal to negative 2x plus 4. So y-intercept of 4 and a slope of negative 2, so down 2 over 1. So we'll do that a bunch of times. And then graph our line. Well, that's close enough. Oh, not so hot, is it? And then do the second one, x minus 3y is equal to negative 5. So negative 3y equals to negative x minus 5. Divide everything by negative 3, and I get that y is equal to positive 1/3 x plus 5/3. That is not a happy situation. Plus 5/3. Well, okay, so that is not going to happen to you on your worksheet that you're going to do tonight. But let's just see what happens here. We have 5/3, which is about 1 2/3, so we'll put that on there. It has a slope of 1/3, so I'm going to go up 1 and over 1, 2, 3. Now we can kind of guess there, and then once we do that, down 1 and backwards 1, 2, 3. And we can guess even though it has some pretty poor graphic there, we can see pretty obviously what that intersection is going to be. So the intersection is this spot right here, which has an ordered pair over 1 up 2. So 1, 2. So you always want to check, because graphing is, as you can see from my lovely lines there, is an approximate guess of what's right. So depending on how nicely you graphed it, you better check those out. So if I substitute into my first equation, I get 2 times 1 plus 2, and that comes out to be, that comes out to be 2 plus 2 is 4, so that checks. And if I check into the second one, that will give me 1 minus 3 times 2. I want that to be negative 5. 1 minus 6 equals negative 5, and that also checks. So my solution is the point 1, 2. X is 1 and y is 2. All right, so example 2, here I already have graphed y equals 2/3 x minus 3. So if you want to slow that down and take a look at it, you can. All right, so you might go ahead and try graphing 2x minus 3y equals 6. Just stop it, and I will put the answer up, and you can compare your answer to mine. So what did you notice? Whoops, they never did intersect, did they? And in fact, you can see that they are parallel. And we learned about parallel lines in the last unit, and you notice that both the blue line has a slope of 2/3, and the red line also has a slope of 2/3. When their slopes are the same, they're parallel. And if they're parallel for the system has no solution. We can also solve systems by substitution. A lot of people think this is their favorite way to do it. There's steps here that you can follow through, and I'm not going to read them for you. So I will go down and work for that first problem, but you can take time and follow through the steps if you need to. When you're solving by substitution, you need to solve one of the equations for one of the variables. So I have a lot of choices. I have the 3x, I have the y, I have the 6x, the 2y. I could solve for any of those four spots, any of those variables in any of those equations. But the place that's going to be the easiest is the place right here where the y does not have a coefficient. So I'm going to begin by taking 3x plus y is equal to 2 and solving it for y. So y is going to be equal to 2, subtract 3x. So once I solve that, I'm going to take it and I'm going to plug it into this other equation for y. So if y is 2 minus 3x, I'm going to place that in place of the y. So I'll have 6x plus 2, place in my 2 minus 3x, and that's equal to 4. Simplify, so get rid of my parentheses, 6x plus 4 minus 6x is equal to 4. And, oh, wait, what happens? 4 is going to be equal to 4 once I simplify. Wonder what that means. So look at this again and notice 4 equals 4. Is that true or false? Well, that is always true. And if this situation comes up where when I substitute, I get 4 equals 4, something that's always true, there's no x or y involved in it, that means that those are exactly the same lines and there is an infinite number of solutions to the system. They represent the same line. All right, so here's our next example. This time it's kind of nice. It's set up really easily for substitution because I already have x is equal to negative 2y plus 4. So I am going to come and substitute into the top equation. So minus, so put that minus down, and in place of the x, I'm going to put in negative 2y plus 4. Plus 3y is equal to negative 1. So I get 2y minus 4 plus 3y is equal to negative 1. So that gives me 5y, subtract 4 is negative 1, 5y. I'm going to add 4 to both sides, so that gives me a 3, and y is equal to 3/5. And some of you may like to think that y equals 3/5 is not a solution, but it is, and we need to keep going and substitute that in for our x. So we'll have that x is equal to negative 2 times 3/5 plus 4. So that's going to be a negative 6/5 plus 4. So common denominator, negative 6/5 plus 20/5. So my answer is going to be 14/5. So that is an x is equal to 14/5. So my solution then will be x is 14/5 when y is 3/5. So this is the solution to the system. So that means they cross in one spot that we can find. So this is probably one we would not be able to do with a graphing method. It would be hard to get to be able to guess that by looking at the intersection. So here's yet another example of a special case. So we will solve for the top one. Again, you want to take the variable that does not have a coefficient. So I will end up with say x plus 2y is negative 3. So I want to solve it for x. So x is equal to negative 2y subtract 3. It's ugly x. X is equal to negative 2y minus 3. substitute into my second equation for the x. So I get 3 times negative 2y, subtract 3, plus 6y, 9, so that's minus 6y, minus 9, plus 6y is 9. So when I combine my y's, I end up with negative 9 is equal to 9, which is false. And if that's the case, when I try to combine these two together, that means that there is no solution to the system. A third method for solving systems of equations is called I usually call it the addition method. Sometimes books will call it a linear combination method, which is probably more descriptive. Again, here are some steps that you can follow to do that. I won't read them for you. So let's go about working this one with the addition method. When you're doing the addition method, you're going to add the first equation and the second equation together. And the goal in this addition is when you add the two together that you eliminate one of the variables, either the x's or the y's. And this one's really nice because when I add it, I get x plus 2x is 3x. A positive 1 and a negative 1 is the 0 y's. And then 4 plus 5 is 9. Nice. Sounds very easy. And then I'm going to divide both sides by 3 and get that x is equal to 3. Now I'm going to substitute to figure out what y is. It doesn't matter which of these equations I choose. And so I'll choose this top one up here. So I'll make sure when you substitute, you put it in for the x. This time x is 3 plus y is equal to 4. Subtract 3, and I get y is equal to 1. So my ordered pair that's going to be my solution to the system is 3, 1. So this is my solution. If I wanted to check it, which is really nice, check into the other equation. And when I check it, I'd have 2 times 3 minus 1 is equal to 5. 6 minus 1 is 5, and that does check out. So this is my answer. Okay, let's see what's next. All right, so x minus 2y is 5, and 2x plus 6y is 4. This time when I look at it, I see that just adding is not going to get me anywhere. If I add them, I get 3x plus 4y equals to 9. Nothing eliminated. So I'm going to have to force it to eliminate. In order for it to eliminate, I've got to have, in front of my x's, I have to have the same number, both of them say 2's, one of them positive and one of them negative. So if I were to go about getting rid of my x's, I would multiply the top equation by negative 2. So let's do that. So I typically will write this up there next to it because I can easily forget in a matter of seconds what I'm multiplying by, and you probably can too, so write it. So this is going to be negative 2x. The negative 2 times negative 2 is going to be positive 4y is equal to negative 2 times 5 is negative 10. Then I'll copy over the second line, so that's going to be 2x plus 6y is 4. I'm going to add it now. I have a negative 2 plus 2 is 0. Boom, that's what we want. 4y plus 6y is 10y. And negative 10 plus 4, and it's going to be negative 6. What was I thinking with all these fractions? I'm going to divide both sides by 10. So I get y is equal to negative 6/10, which reduces to negative 3/5. So that's my y. Then I need to figure out what x is. So I am going to go back, here to this equation and substitute in. So I'm going to do x. Again, it doesn't make any difference. I just look at what I think looks easier. So x minus 2 times negative 3/5. This time that was a y. I need to put it in. Is equal to 5. So x plus 6/5 is equal to 5. Subtract 6/5, so that's x is equal to 5. Subtract 6/5. Common denominator, so 25/5 minus 6/5 is 19/5. Now, truthfully, I'm a little concerned that that was right, so I'm going to go back and I'm going to check it into my second one. So I will have 2 times 19/5. We'll put check here. Plus 6 times a negative 3/5. We want that to come out to be 4. So that's going to be 38/5 plus a negative 18/5 is 4. Ooh, that's good. 20/5 is equal to 4, and it does check. No matter how ugly it was, it is. The answer then is 19/5, comma, negative 3/5. So solution for the system. So example 6, we've got some fractions that we're going to solve. It says solve by linear combination. We'll just see which one works out easiest for that. But what do you do when you've got fractions in equations? That's right, we're going to multiply through by that common denominator. So I'm going to come across the top equation, the LCD is 6, and I'm going to multiply everything by 6. So I get 2x minus y is equal to 3. Then I'll come across this second equation and multiply by the common denominator, which is 4, and we'll come up with 2x plus y is equal to 1. Once again, very nice, because I can add, my y's eliminate very easily, and I get 4x is equal to 4, x is equal to 1. Now, when I substitute to figure out what y is, I am not going back up to the fractions to do it. I'm going to substitute in either this blue or red equation. So since y is positive in the red one, let's substitute there. So I'm going to come over here and say that I've got 2 times 1 plus y is equal to 1. So that's going to be y is equal to 1, subtract 2, y is equal to negative 1. And just to be sure, let's check it. Let's check it back up on top, to that very top one. So, yeah, let's check into the top one. So I've got x over 3, so that's going to be 1 over 3 minus y over 6, so that's going to be a negative 1 over 6 is equal to 1/2. So common denominators, that's going to be 2/6 plus 1/6 is equal to 1/2, and that does check. So we're happy. My solution is 1, negative 1. So there's my solution to the system. And I think that's it. Worksheet 4, homework.